Welcome. It is my privilege to introduce our guest today, German scientist Dr. Wolf-Ekkehard Lönnig. Worked for 25 years as a research scientist at the Max Planck Institute for Plant Breeding Research in Colonia, Germany. He conducted in-depth research in genetics as well as physiology and morphology of plants, publishing and peer-reviewing dozens of scholarly works in these fields. So, Dr. Lönnig, to what extent do you think that your studies on the genetics of plants and biology in general confirm or deny the intelligent design hypothesis at a theoretical level?
Well, your question. My first larger study on the genetics in plants was with the garden pea. You all know the garden pea. Can this be seen? The garden pea.
Yes.
This just to remember how such a plant looks like. And important is to know that the genetical laws were detected in the garden pea. It was Gregor Mendel, the monk in Bonn. And the genetical laws, which are true for plants, are also applicable in animals and are also true for man. So this is plants are the genetics in plants have been the basis for the entire field of genetics. And my first it was in garden pea for my PhD doctoral thesis in science on the topic of heterosis. What is heterosis? Heterosis, also called hybrid vigor, is the increase in such characteristics as size, growth rate, fertility, and yield of a hybrid organism over those of its parents. Just to show you how this looks like, you have here the parents, the mother, the father, and this is a child, to speak in general language. Yes. So the child is almost twice as high and long as the child as the parents. This is an example of heterosis, of hybrid vigor. So the parents are both small, and the child is, well, is almost 2 meters high. And when I carried out my investigations in 1978 and 1979, and some of the following years, heterosis was a very hot topic, thought to be one of the main arguments and proofs for neo-Darwinism, and that this theory could not be doubted for any scientific reasons. Now, we have just seen that when crossed with each other, certain pea lines displayed an extraordinary strong hybrid vigor. So you may ask, what has this to do with evolution? Well, the idea was, and to some extent still is, that the disadvantageous effects of a mutant gene are overcompensated by the interactions between the mutant and the wild type gene, say capital A, small a. So that size, growth rate, fertility, and yield are larger, producing more offspring, and that the mutant can then, under the shield of that heterosis effect, can further evolve until a better function is reached and further evolution is guaranteed. Well, this was a basic problem for my doctoral thesis. I must admit that on my background of all the strong convincing arguments for intelligent design, for the origin of life and in its many forms, I was very skeptical that this interpretation would be true. Heterosis or hybrid vigor due to heterozygosity in the alleles of one gene. What are alleles? There are different versions of genes. Each version is called an allele. In the present case, a wild type and a mutant gene. I thought, well, it could perhaps be true, but it appeared to be somewhat improbable for me, because if you have a mutant gene and this mutates further on, it is, if it is half destroyed, it's then totally destroyed by further mutants. And so I was very skeptical. And when I started this work on heterosis in P, the heterozygosity interpretation had already been published several times, 5 to 6 times, by my big boss. I don't call the name, and I don't say the name, by my big boss of the Institute of Genetics at the University of Bonn. And it was also a part of a textbook wisdom. It was also in a textbook as one of the good arguments for the correctness of Darwinism. Well, to make a long story short, the investigations with altogether more than 10,000 pea plants proved the evolutionary hypothesis to be essentially and, well, almost totally wrong. The real reason for the hybrid vigor was this: the parent pea plants, pisum is the Latin name of the pea, of the different mother and father pea lines each had different mutant genes, so that the father as well as the mother both possessed also those correspondingly fully functioning wild-type genes. And in the hybrids, the dominant wild-type genes of the mother and the father compensated the disadvantageous effects of the different mutant genes, so that the hybrids displayed increased size, growth rate, fertility, and yield. Well, that's a bit complicated, very, very fast, but nevertheless, you may look into my doctoral thesis if you speak German, of course. But there's also an English publication which treats that topic. Well, the acid test that the new interpretation, which I suggested due to my experiments and my work on the field or in the field, the acid test was to obtain recombinants of plant lines displaying and directly passing on that hybrid vigor to their descendants. So not again crossings, not again all the work with this with 2 different lines, but just self-pollinating the new, long, more fertile lines. Well, self-pollinating, this is what the bee itself does. So the big boss of the institute was very skeptical of these results, but he himself repeated these scientific field experiments and investigations to be sure that he did not have to correct even the textbook, but after all, and finally, he fully agreed and correspondingly published the new corrected results. So one important argument for evolution refuted by the genetic facts. This is just an example. The outcome was in full agreement with one of the more important basic predictions of the intelligent design theory. Mutations usually do not produce any real new information. The heterosis phenomenon, the hybrid vigor phenomenon in peas was just due to losses and restoration of original information, restoration, losses and restoration of original information, which was still present in the parents, although distributed between the 2 parent lines. So, to accept intelligent design, in and to be critical of evolutionary arguments and put them to the test can be very fruitful for biology and science in general, and even be the basis for a doctoral thesis. The next point which I would like to mention is the law of recurrent variation. The present neo-Darwinian theory of evolution focuses on mutation and selection. Famous biologist Ernst Mayr, he was one of the founders of the neo-Darwinian theory or synthetic theory in the 1940s, stated, in essence, this new theory is a two-factor theory, considering the diversity and harmonious adaptation of the organic world as a result of a steady production of variation and the selective effects of the environment. It is thus basically a synthesis of mutationism and environment. And he also says it must not be forgotten that mutation is the ultimate source of all genetic variation found in natural populations, new material available for natural selection to work on. Similarly, I have dozens of biologists in one of my in that book, for example. I have quoted dozens of biologists saying this, principally the same thing. For example, one of the more renowned geneticists was this Gustafsson, and he said that if DNA had been unchangeable, our Earth would have been barren and as lifeless as the surface of the moon. It was totally, would have no life on Earth. It was so lifeless as the surface of the moon, and many others. So the basic teaching today still is, and it is all the more in high schools and universities, without mutation, no evolution, no new life forms, no new bauplane, our Earth, as said, would be barren, lifeless as the surface of the moon. Well, in my paper about mutation breeding, evolution, and the law of recurrent variation, I noted the following. Since the origin of cultivated lines, like the pea lines, or many of them, a thousand other cultivated lines, was thought to be indispensably due to the same factors as the origin of species in the wild. So it has been reported that an enormous euphoria spread among biologists in general and geneticists and breeders in particular, and that the time would have come to revolutionize the old method of recombination breeding, often lasting 10 years and more, by the entire new branch of mutation breeding. Now mutations were put to the test by the breeders. Now, in the experimental fields, I noticed that many similar mutants had appeared and reappeared regularly in many independent mutation experiments. Also, many further researchers had also noted this phenomenon. For example, quote a famous geneticist, Hans Stubbe, after 40 years of intensive mutation research in Antirrhinum, the snapdragon, just to show you a snapdragon, you most probably, this is a snapdragon Antirrhinum majus, Antirrhinum majus. And he had worked for more than 40 years with that and mutagenesis experiments. He said, he summed up his studies as follows. The continually a quotation, improved knowledge of mutants in antirrhinum has provided some essential experience or results. During the years, each new large mutation trial showed that the number of really new mutants recognized for the first time was steadily diminishing, so that the majority of genetic changes was already known. Similarly, another famous geneticist, the larger the mutant collections are, the more difficult it is to extend them by new mutation types. Mutants preferentially arise that already exists. To make another long story short, the result of mutation breeding has been summarized as follows. 3 different time-lapse methods complementing each other for a complete success in a rather short period of time, were at the disposal of the breeders. A, 1,000-fold multiplication of mutation rates. B, well-aimed recombination and intelligent selection. So things that would normally need thousands, perhaps even hundreds or millions of years, could be now come together due to these 3 time-lapse methods just mentioned. And the result, well, was the following. Many programs failed to produce quotations of plant geneticists who had tried to improve pea lines and other cultural varieties by mutations. Almost all mutants distinguish themselves by negative selection value. All kinds of mutations are even more frequently lethal and more strongly diminishing vitality and fertility in animals, where they tried to all the mutation breeding in animals, but this was totally stopped. The results was so negative that they stopped it altogether after not a long time. In spite of enormous financial expenditure, mutation breeding widely proved to be a failure, and so on. It was also modified the methods, but the overall result was that these strong anticipations, this euphoria at the beginning, concerning a revolution in plant breeding, among geneticists and agronomical scientists after the Second World War, ended up in a worldwide failure and breakdown of mutation breeding as an autonomous branch of breeding research in the 1980s, at the latest in most Western countries. Mutation breeding has shown the limits of variation by random mutations. There was never a new species has been generated. Well, even we had 2 experimental fields at the Bonn University. And I remember when the breeders came and looked at the plant of the pea plant, the mutants, there was not even one new variety which was accepted by these plant breeders. But what has happened time and again, this same or nearly identical phenotypes were repeatedly or occurred time and again. And so, but no new, entirely new plant forms and plant species which could be survive in the wild have been found. So I formulated the law of recurrent variation that just to name that, if you make mutation experiments, repeat them, so that virtually all genes have been mutated, you come to a limit of of variation. The variation is enormous, but it is not without limit. It shows limits. And this I have published as the Law of Recurrent Variation. Another point which I would like to mention is this. When during these experiments, I have found repeatedly what has been called systems of irreducible complexity. But before I come to that point, I would like to quote the summary of that law of recurrent variation. It is this. The law states that treating homozygous lines with mutagenic agents generates large but clearly finite spectra of mutants. This consistently occurs when the experiments are carried out on a scale adequate to isolate the potential of alleles causing phenotypic and functional deviations. It's called saturation mutagenesis. However, due to almost invisible residual effects of changes in redundant sequences or further chromosome rearrangement, the corresponding saturation curve is asymptotically approaching its limit for the micro-quantitative part of variation. So this is in just a very few sentences, the law of recurrent variation, which I have published. You can find it also on my internet site. They can read all these things, what has been done. So the other point, which I've just mentioned, is irreducible complexity. Well, Michael Behe defined, by irreducibly complex, I mean a single system composed of several well-matched interacting parts that contribute to the basic function, wherein the removal of any one of the parts causes the system to effectively cease functioning. Well, and I've found in my experimental work many such examples. I've just mentioned the chlorophyll mutants. These are mutants in the genes involved in the formation of the photosynthetic apparatus. Many of the mutants which occurred were absolutely unable to proceed with any photosynthetic at all. They were purely white. You could see the little plants starting to grow, the seedlings, and then they died. And the question is, does this not show that there's an irreducibly complex genetic core system which could not be generated, as Darwin and Darwin postulated, by numerable slight variation? So, but if a system depends on a set of, let's say, 50 or 40 genes, and if one is mutated, the entire system breaks down, then you cannot build that system up by slow degrees, by slight variations, but you must, and such a system can function only, the core system, if all these necessary parts are there. So this is for mutation breeding, and this is also in full accord with the intelligent design theory, which predicted that mutations can broaden the variation of, let's say, as example shown the pea lines or bean lines or maize lines, and there are thousands of many others. So the point is, this is in full accord with the expectations due to the intelligent design theory, which postulates that for new complex information, intelligence is necessary. But you can destroy mutant genes, and you can destroy genes by mutations. Another example is which I also was published by my boss and me. It is a system I just showed you, that antirhinum mutant, and I've also worked with these with antirhinum mutants. And this antirhinum plant, this snapdragon, there are mutants which are called cycloidea. I hope this can be seen. They are very strange forms. You see, there are long flowers which strongly deviate from the phenotype of the normal antirhinum zygomorphic flower. And this is called cycloidea. It is always is a radial, a kind of radial mutant. And this has been published many times as one of the great ideas corroborating neo-Darwinian evolution. You see, so this zygomorphic flower has been evolved from a radial flower. This was the idea behind it all. Now, I made experiments, and this I should perhaps say that what is zygomorphic? You have just seen that normal antirhinum flower is a flower having only one plane of symmetry. This is also in the pea with just one plane of symmetry.
Dr. Lönnig, it's better if you move the image a little bit up, so it will be.
Okay.
Okay, yes. and move it on the side a little bit.
Can it now?
No, the other side. The other side.
Other side.
Yeah. Okay. Yeah. I mean, just in front of you, so it will be better to see. Yeah.
So.
Okay. Perfect.
Now.
Yeah, it is better.
Just have it in front of my face. Okay.
Okay. Thanks.
Yes. So this is a zygomorphic flower, having only one plane of symmetry, like the pea and the snapdragon. And the others, the radial mutants, one can well argue that it has several planes of symmetry. Yes, again, you can see it now. Again, here, these are the, and this was also sold, I would say, as a big argument, a very valuable argument for the correctness of Darwinism and evolutionary theory. So, my first critique was that the zygomorphic plant species, if you take different ones, they and even some of the same give rise to distinct kinds of radial mutants, differing strongly from one another in their morphology, so that several authors have rejected the interpretation of atavism. So, as atavism meaning that it turns back to the original state of the anatomy. So, a species cannot have different looking ancestors at the same time. Now I looked and studied that anatomy. The radial flower form of antirhinum is often due to 5 to 6 times repetition of a flower part already differentiated and organized for the zygomorphic flower. Well, if you take, it was done, it was, if you take just this part and you reduce the other parts and repeat it for flower formation, then you get a radial one. But this part is already a differentiated, anatomically differentiated part of the normal zygomorphic flower. So this cannot be the origin of the antirrhinum.
Dr. Lönnig,
Yes.
let me ask you, in the course, you anticipated already a little bit, but maybe you can focus a bit. In the course of your experiments, have you been able to empirically apply any inference to intelligent design?
Well, I will come back to that later. Okay.
Okay. Perfect.
Well, empirically, a few moments ago, I mentioned the mutants of the photosynthetic apparatus. This is an empirical argument for a irreducible complex system. This was an empirical example. But I can come back to, I hope so, further. Well, to make a long story short again, it has been published in a genetical journal. The middle part of the lower lip with the lobe, gibber, and spur, and further structures have been duplicated and repeatedly produced so that they're now a radial form. And the point is, this cannot be as already mentioned, that. So there's another long topic that is transposable elements. But this would be a topic of its own. We need a quarter of an hour just to talk about that one. I've made investigations with transposable elements with literally hundreds of thousands of plants. In spite of many speculations how TEs could be important for macroevolution, no new species have been ever generated by transposable elements in all the experiments with millions of plants and also with neither with the fruit fly Drosophila melanogaster. But this, and now I come back to a second question. Can you please repeat that second question?
Yeah, of course. I'm just curious to know if in the course of your experiments you've been able to empirically apply any inference to intelligent design.
Yes. Well.
Yeah, as you said, you anticipated a little bit of that, but maybe you can focus a little bit on
yes,
on this application.
Whenever you make such mutation experiments, you obtain not only chlorophyll mutants that's mutants in the photosynthetic apparatus, but also many more lethal mutants, which grow a bit and then die away. And many even do not start their development because if you have a basic mutant genes which are necessary to start the development of a plant, if these genes don't function anymore, then this is another example of empirically applied an inference in the experiments that mutations can kill, but they don't produce entirely new species and entirely new information which is necessary to build new plant species, new plant genera, and families and orders and so on. And the same in animal, of course. In animals, I mentioned at the beginning that the mutation breeding in animals has stopped very soon because it was so totally negative that animals can feel pain. So they stopped it entirely. If you have for example, if you have a plant which produces a poisonous structure, but you cannot eat that plant because of the poison which it produces. And if such a gene necessary for poison production is switched off, is mutated, then it is possible to further investigate whether the plant can be valuable for nourishment of humans and animals. You have examples that such a poisonous plants plant species can now be eaten because due to a mutation, the production of poison stopped. I mentioned Ernst Mayr a few minutes ago. That it is a two-factor theory nowadays. It is mutation and natural selection. And geneticist Heribert Nielsen said, the Darwin opponents soon asked, can the struggle for existence create? It can and must eradicate, hence kill, but it can't create anything. A good example, just as a sieve cannot create new grains, but can only sift the existing ones. So natural selection cannot produce any new species, and it needs new grains to select. If mutations don't produce them, then it does not function. So, but you wanted to say something. You asked something further. I would, of course, mention also, I have worked about plant goals and evolution and many other topics, but this would be a very...
No, it's very, very much.
I've also worked about orchids. And
yeah, it's very interesting
paper.
because all the details that you provided get us into the specific facts that your research found out. So this is very important, and I do thank you. I just wanted to ask you, how did the scientific and academic community receive your support to intelligent design, especially within the circles that you were actually part of?
Yes. I showed you that book a while ago,
yeah.
but
Yes.
I have written about that topic, another book. It is the Max Planck affair, which never happened.
Aha, so it deserves a book to explain.
Yes, I have written a book about that.
Can you just get us the idea for our viewers? Yes. It would be very interesting. Yeah, go please.
I would like to mention also that I have also worked in the fields with the lesser snapdragon. This is a smaller one, and I also have worked with physalis, which can be eaten, and large mutation experiments with altogether 2.1 million plants. I have worked during these altogether 32 years, and it has all these results showed the regular appearance of certain mutants in very different plants, very similar mutants in very different plants. It is a regular appearance of certain mutant phenotypes, which is in accord with the law the law of recurrent variation or recurrent variation. Now you are, I could say that the circles I was an active part of, they're usually rather tolerant. Although sometimes there were also very exciting, not to say stressful situations. My PhD supervisor was sometimes not so happy. Now the results from the experimental fields and his fine argument for evolution due to hybrid vigor all gone, and then this terrible person, Wolf-Ekkehard Lönnig. But when he himself did the experiments again, and he detected that he was wrong. He corrected himself and published the new hypothesis, or the best explanation is dominant genes working together to produce that hybrid vigor. I would say, perhaps a bit ironically, I've got the privilege to have been the target of false accusations, denouncement, and even, well, outright hatred of radical neo-Darwinians, starting especially in the year 2002 and then onwards. At that time, I was doing research at the Max Planck Institute for Plant Breeding Research in Cologne, Germany, since 1985. The totalitarian materialists and neo-Darwinians, well, I do not want to name the persons. I can, there was 3 professors, one from Kassel, one from Würzburg, and one from Konstanz, of universities. And they tried everything to discredit me. So all these things came from outside the institute, not from inside the institute. They come from outside the institute. They tried to apply pressure to its directors, even to 2 presidents of the Max Planck Society, to close my homepage that was invited, and to close it, and then with the implicit goal to get me fired. This is what their real aim was. As such a person as I am, could not be tolerated in times. Critically looking at our holy cow, which cannot be doubted anymore, the fact of evolution and neo-Darwinism. The fact of. Then there were also doubtful comments in leading German magazines, Der Spiegel, Focus, Die Zeit, and others. And even in Nature, not to speak of the polemics issued on the internet. But one of the main targets of their argumentation was my religious affiliation to Jehovah's Witnesses. And they say, well, such a person cannot be doing science. And I have called this a declaration of bankruptcy due to the fact that they were unable to cite real scientific facts and counter-arguments against the views which I had entertained. And so the entire, all the attacks were produced without any scientific arguments against the things which I had published, and I've been going on to publish. This is neo-Darwinism and evolution at the beginning of the new century. But I thank God they were not successful. So in Germany, you have to retire at the age of 65. And this is, and the relationship to my big boss, Cologne, is still fine.
This is,
But
at some extent, it's a comfortable piece of news. Yeah, I'm very glad to hear about that. So, Dr. Lönnig, thank you so much. Your studies and the ostracism that you suffered, at least from some circles, testify your untamed dedication to scientific truth. We are very honored to learn from your expertise, and we invite our audience and viewers to go into more details through your many publications, many books. There is much food for the brain out there to
may I
look.
interrupt you again?
Yes, you
Yes.
can, of course.
I would like to say something
Please do.
positive,
Yes.
a scientific argument for intelligent design. I quote a professor of botany from the University of Münster. He said, the cell is the most perfect cybernetic system on Earth. And in comparison to the cell, all automation of human technology is only a primitive beginning of man in principle to arrive at biotechnology. And one can add, the cell is the most perfect cybernetic system on Earth, usually consisting of thousands of spatio-temporally precisely matched gene functions, gene interactions, cascades, and pathways in a steady state network of ingeniously complex physiological processes, characterized by specific as well as often irreducible complexity, including an abundance of information to at least the giga and to terabyte range and more. Now, the conclusion, the inference is, if the first steps on the way, the path to the ingenious level of cybernetic complexities of the cell, it is a primitive beginning in Stroger's formulation, demands conscious actions, imagination, perception, intelligence, wisdom, mental concept, spirit, and mind, all being already necessary for the basic start. So how much more does this have to does this have to apply to the origin of this 1,000 times more complex cyberneticism of life in all its forms, including all the specified and irreducible complex structures inescapably necessary for the origin of man, also of the origin of man. I've written a paper about the origin of man. You can look all the books which you have seen. You can all check on my homepage in the internet. You need not buy anything. You can directly go and check these things.
Thank you. It's been very important.
No, this is one of the most important arguments in my view, but there are many more, of course, as specified and irreducible complexity and the enormous amount of information necessary to produce new life forms.
Thank you, Dr. Lönnig. It has been a very special pleasure. Il Centro Italiano per l'Intelligent Design ringrazia il professor Lönnig per la dettagliata descrizione dei suoi studi e delle prove a conforto dell'intelligent design che la sua onorata carriera ha potuto mettere in fila e come ci ricordava poco fa, disponibili per chiunque per ulteriori approfondimenti. Da parte nostra non c'è che ringraziarlo per questa prova di scientificità e di capacità anche di sopportare critiche malevole dettate soltanto da forse gelosia, forse poca serietà nei confronti della scienza.